So you can see here is my polynomial, x squared plus 5x plus 6. And it tells me to factor this polynomial. Factor x squared plus 5x plus 6. So is there a GCF? Well, look at the coefficients, 1, 5, and 6. That would be a GCF of 1. Do they all have an x? No. So I have nothing I can factor out. There is not a GCF other than 1, which again doesn't do a lot for me. Okay, so what we're going to look at today is this is a 3-term polynomial that's in the form ax squared plus bx plus c. This is what we call a quadratic. A quadratic. And we kind of looked at that word earlier. So quadratics are in the form of ax squared plus bx plus c. We call it quadratic because what degree is this polynomial?
Third.
Degree. Degree. It's a second degree polynomial. You see how the terms go from second degree to first degree to 0 degree. It's in standard form and it has 3 terms. It's a quadratic that's a trinomial. Right? 3 terms in this form. Everybody understands? You're learning a very specific way to factor. It needs to look like this.
What's the name for the second degree? Is it just second degree? Or
Second degree is quadratic. A second degree polynomial is called a quadratic. Okay, so here is how we're going to factor it. This quadratic is in the form ax squared plus bx plus c. A is the coefficient in front of the x squared term. Right? A is my leading coefficient. It's just going to be a number. Does everybody follow that? So in this problem, what is my A term? A is 1. Because what's in front of the x squared term? There is no number we see, so there's an understood 1 there. So in my polynomial, the A term is currently 1. What is the B term in my polynomial? It is 5. The B term is the coefficient of the x variable. X to the first. And then the C term is the constant. It's the one that has no x. What would the C term be here? 6. Is everybody okay with identifying the A term, the B term, and the C term?
Yes.
Do you need practice with that again? Identifying A, B, and C. Okay, so here is how we factor it. It's called the A times C method. So we're going to multiply A times C. So in this case, that is 1 times 6. So A times C gives me a value of 6. What are the factors of 6? Let's start with 1. I always like to start with 1, guys. So we've got 1 times 6, 2 times 3. Now I've completed the whole list, right? Because I went from 2 to 3. I've already got 3. That's the only factors of 6. Okay, now, what we have to look for. We're going to pick one of these pairs. We're going to pick one of these pairs as a way to factor. We want to pick the one that when multiplied together gives me a positive 6. Okay, so what could these numbers be that multiply to be positive 6? It could be a positive 1 times a positive 6, or it could be a negative 1 times a negative 6. It could be a positive 2 times a positive 3, or it could be a negative 2 times a negative 3. How do we know which one to pick? Well, it needs to multiply to be positive 6, but when I combine them, add or subtract, they need to combine to be the B term. They need to combine to be positive 5. So they're going to multiply to be 6, but when I combine them, they're going to give me 5. Positive 5.
Wait, how would,
3, 4,
how
5.
would you, I'll just let you explain.
So, and again, there's a lot going on here. So can 1 and 6 combine in a way that gives me 5?
Yeah.
If I subtracted them. So if I got 6 minus 1, that would be 5. But then I would be multiplying a positive and a negative. You see how they're different signs? And I said they had to be the same sign. So the only way I could make 5 here with 1 and 6 makes me have opposite signs. So that one's not going to work. Can I combine 2 and 3 to get 5? Yes, a positive 2 and a positive 3 combine to give me 5. So does a positive 2 and a positive 3 combine to be positive 5 and multiply to be positive 6?
Yeah.
So those are the two terms. All right, that's the two I'm going to use, is 2 and 3. Everybody kind of follow. I know there's a lot going on. It's a totally new process. And the first time I've ever taught it. So I could be a little scatterbrained here. What we're going to do is we're going to take our B term, which was currently 5x. And we're going to rewrite the B term as 2x plus 3x. Because what is 2x plus 3x? 5x. I'm not changing the number, I'm changing its form. And I chose 2x plus 3x because that's the ones that fit my criteria. Was 2 plus 3. So now what I have is I'm going to bring down the x squared
Is
plus,
it always going to be like this has to combine to be like the C term and this has to combine to be the B
yes,
term? Okay.
yes. These all work very similarly once you get the pattern down. So I've rewritten 5x to be 2x plus 3x. Is everybody here now?
So, wait, I got a question. So, you're trying to find, C, which is 6, use the GCF of that to get B.
Not necessarily the GCF.
Or like,
The factors.
the factors, yeah, the factors.
I'm looking at the factors of A times C
Of A times C to get B.
to find what can combine to give me B.
Okay, I got you.
The factors of A times
And
C.
you would always-
Everything today, every A term is going to be 1 today.
Yeah.
We're going to make it kind of simple. But we're going to eventually look at what if there's another number out here.
Can we do one that's a different number?
Not today.
If
We're going to Wednesday. We're going to start with all of them being 1.
are we always gonna add an
It's the same
X-
process.
an X to the end of those two
Yes.
factors?
Because we're taking the B term, which is 5x,
Yeah.
and we're rewriting it as 2x and 3x.
So why wouldn't you put 2 times 3 where 6 is?
So what about when you have 4 terms?
You can, but that's not going to help me factor.
Okay, okay. I got you.
What about when you have 4 terms?
Well, now we have 4 terms, right? I've taken my 3-term polynomial, I've given it 4 terms. Here is how we factor when we have 4 terms. We factor by grouping. So what we're going to do is we're going to group the first 2 terms together. Let me pick a different
I
color.
thought you were about to just do like terms.
Nope. If I did that, I would just be going right back to what I started with, right? Remember, I'm learning how to undo stuff. Factoring is how to undo.
Can we just solve the problem?
And we're not solving. There's no equals to sign yet.
Distribute.
No, we're not distributing.
We're factoring.
We are factoring. So now I've grouped the first two terms together and the last two terms together. Look at the first two terms. Do the first two terms have a GCF?
Yes.
Yes. So I'm going to take the GCF of the first two terms. See, you gotta know how to do the GCF? What is the GCF here? 1x. Y'all guys always leave the variables out. They both have an x. So x is the GCF. So I'm going to factor out an x. Now what's left in the first set of parentheses if I factor out an x? X to the second becomes x to the first. 2x becomes
X.
just
Oh,
2.
Yeah, you get away with it.
Just 2.
Yeah.
Oh my gosh.
Welcome to Algebra 1, guys. Now I'm going to look at the second set of parentheses. Do they have a GCF? They do. What is it? 3. They both have a 3 in common. So I'm going to factor out a positive 3. Now what's left? If I factor a 3 out from 3x, I'm left with only x. What happens if I factor a 3 out of 6? I'm left with 2. Remember, we're dividing. So I'm left with a 2. When you do the A times C method, you will know it has worked if, when you get to this point, your parentheses match. If your parentheses do not match, you cannot do the A times C method, or you messed up the A times C method. Parentheses have to match. So this factors to be what's in front of the parentheses, which is an x plus a 3, times the matching parentheses, which is x plus 2. So I took the terms in front of the parentheses, x plus a 3, and I multiplied that by the matching parentheses, which were x plus 2.
Is that the answer?
Is it factored? Factored means I'm multiplying two things together.
Oh, yeah.
I am. I'm multiplying x plus 3 times x plus 2. I factored.
There's no shorter way to name do this.
There is on these if you can spot them and recognize them. The more you do these, you might be able to figure out what they are. Like, I was never taught the A times C method. I was always taught trial and error. So like, we would make our list here, and then we would just try different numbers in here. And if the list was long, then you'd have to try 15 different things. Or you got good at seeing it. Well, I've taught you guys math. You're not going to be good at seeing it. So I'm teaching you the method that works every time. Down the line. The A times C method. This will also help you when you get the harder ones that have a number out front. Just trust me, I think this is the best way to factor.
What was the longest list you
Okay, here. We want to factor this.
But then you're not going to have lots. So.
Factor x squared plus 13x plus 36. Number 1. Is there a GCF? Which is useless. They all share 13? No. Remember, a GCF must be shared between all three terms. There is no GCF. Because if there was a GCF, that would be easy to factor. We just factor the GCF out. There's no GCF. It's not a special case. We have three terms. Is this a trinomial that's in the form ax squared plus bx plus c?
Yes.
You see how it's in that form? So I'm going to do what? I'm going to multiply a times c. I'm going to do the a times c method. In this case, that would be 1 times 36. 1 times 36, which is 36. So now, what are the factors of 36? It could be 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't work, 6 times 6. You see how important it is to know your multiplication tables?
No.
Or you're going to have to plug all these into your calculator every single time.
I'm glad I learned.
Now we're going back to 3rd grade, and can you multiply?
I can't believe there's still people who can't multiply. I'm sorry.
There's a
if that
bunch.
offended you.
There's people in here. Okay, so these need to multiply to be a positive 36. They have to multiply to be positive. That means that the signs must be the same. They must both be positive or both be negative. When I combine them, they need to combine to be positive 13. So that means if they both must be the same sign and they both must be positive, to combine to be positive 13. So what can I combine here that gives me 13?
4 and 9.
4 and 9. 4 times 9 is 36. 4 plus 9 is 13. Everybody in? So we're going to do what? We're going to rewrite our b term as 4x plus 9x. And then bring down the plus 36.
I think I got the answer.
This is not as bad as y'all make it be, right?
When you first just started putting...
Well, there's a lot to it. It's new.
Yeah.
It's new.
That was a dang
But I think it's fun. Okay, so now I have written this as 4 terms. When I have 4 terms, the way I like to factor is to factor by grouping. When I factor by grouping, I look for the GCF in the first 2 parentheses. Do I have a GCF here? 1x. They both have an x. That means x is the GCF. What happens if I factor an x out of x squared? That leaves me with x. What happens if I factor an x out of 4x? That leaves me with 4. Are you sure you got the GCF down?
Yes.
Okay. Now, the second set of parentheses, do they have a GCF?
Yeah.
9. 9 goes into both of those. So I'm going to factor out a positive 9. If I factor a 9 out of 9x, what am I left with? X. If I factor a 9 out of 36, what am I left with? 4. 36 divided by 9 is 4. When you get to this point, when you've taken the GCF out of both groups, you need your parentheses to match. If they do not match, you did not factor correctly. So they match. Good. That means this factors to be what's in front of the parentheses, which is an x plus 9, times the matching parentheses, which is x plus 4.
Okay, it wasn't that bad.
My teacher
Do you have to put...
I think I did it like backwards and things. I think it was a different way. I think like we either maybe like we just saw it differently instead of like I don't know. But I remember like knowing that x plus 9 was supposed to be in parentheses like before. I don't remember how, but I just remember doing it.
They made it different.
Yeah.
This is the way I did it.
You always put the
I
largest
don't
number in
know. I
front.
don't care.
Like, you have x plus 9 in parentheses. Can you put x plus 4 in parentheses and then x plus 9?
You could. It doesn't matter.
So it doesn't matter.
Same thing.
Okay.
because multiplication is commutative. 3 times 4 is 4 times 3. So if I've got the parentheses completely flipped, that's
I
fine.
mean, either way, when you double check, it's gonna come out.
That's correct.
And I already feel as a first.
So again, we can check this. How do we check it? If I have x plus 9 times x plus 4, distribute.
Multiply that
This is just a way to check. X times x. X squared. X times 4. 4x. 9 times x. 9x. 9 times 4. 36. Do I have like terms? Yes. 4x plus 9x is 13x. That means I've done it correctly. Okay, so this is in the form ax squared plus bx plus c. There is no GCF. They don't all have an x. They don't have a number that's common to all of them besides 1. Because this is in the form ax squared plus bx plus c, I would do a times c. 1 times 28 is 28. List the factors of 28. That could be 1 times 28, 2 times 14, 3 doesn't work, 4 times 7, 5 doesn't work, 6 doesn't work, 7, I'm through the whole list because I've already got a 7 on there. So those are the factors. Now, because this last term is positive, that means these factors have to have the same sign. And that same sign is going to be whatever this is. So they both need to be positive. So which ones here combine to be positive 11? 4 plus 7. So 4 and 7 is how I'm going to rewrite my b term. So this becomes x squared plus 4x plus 7x plus 28. I've rewritten it as 4 terms. Questions, or am I good to keep going? I'm going to factor by grouping because I have 4 terms. Group the first 2 together. The GCF of x squared and 4x is x. That leaves me with x plus 4. The GCF of 7x and 28 is 7. That leaves me with x plus 4. At this point, your parentheses must match for grouping to work, and they do. That means this factors to be what's in front of the parentheses times the matching parentheses. X plus 7 times x plus 4.
What we've been doing, lesson quiz, lesson practice, same thing, over and over.
Okay, let's factor this one. X squared minus 11x plus 18. Is there a GCF? No. It's a trinomial, 3 terms. Is it in the form ax squared plus bx plus c? That means I can factor doing the a times c method. So here, a times c gives me 18. What could multiply to be 18? 1 times 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work. I've already got 6. That's the whole list. Now, because the last term is positive, the c term is positive, that means that my factors must have the same sign. The sign they're going to have is whatever the b term is, which is negative, right? My c is positive. My 2 factors will have the same sign as b, both positive or both negative. So I need to pick over here. They're both going to be negative. Which 2 of these, both negative, combine to be negative 11? A negative 2 minus 9. Negative 2 minus 9 combines to be negative 11. So we're going to rewrite the b term as negative 2x minus 11x. Right, that's the one that worked. It's not 11. I'm an idiot.
I was
2 and
the one
9.
that did that.
2 and 9. 2 and 9. See how easy it is to make a little mistake?
I thought I had already messed up.
Nope, I did. I got carried away.
So what's gonna change when we have?
So
that
it doesn't
number in
matter.
Nothing with the process. But you're not going to be able to do it by just looking like you can here. It's going to be harder to look and do it. But the process is the exact same. That's why I'm teaching it this way.
How is it gonna be harder?
Well, I mean, I'll show you.
Okay.
It's not if you learn this process. It's not any harder. But if you try to do it by looking the way you're doing,
The way I'm doing it now?
it's going to be harder when there's an A up there. I'm just telling you. But nothing changes from this. It's the exact same. Now, 4 terms, so I factor by grouping. What is the GCF of the first 2 terms?
1x.
X. They both have an X. So that's going to leave me with X minus 2. Now when I look at the second set of parentheses, what's my GCF?
-9.
-9. -9. Because I like the leading coefficient to be positive. So
What?
what if, just watch, what if we took out a GCF of +9? Don't write this down, just watch. What would happen if I took out a +9?
Then you would have,
What's left?
you'd have negative x.
Negative x. And then what's 18 divided by 9? +2. So now, do my parentheses match?
No.
No. What's wrong with them? They have the same terms, but they all have the wrong sign. This is what happens if you take out a GCF of +9. That's why we need to take out a GCF of -9, because it will change all those signs.
Wait, I got a question.
Yeah.
How can you have -2 and -9 and then it 30?
Negative times negative.
Oh, never mind. I'm tripping. I hadn't realized that. I'm sorry.
So if I take a GCF of -9, -9x divided by -9 is x. 18 divided by -9 is -2. Do my parentheses match? Great. That means the A times C method worked. So this factors to be what's in front of the parentheses, x minus 9, times the matching parentheses.
The only time they won't match is if the C is negative.
Not necessarily, if you take the wrong GCF out. Or if you pick the wrong 2 terms. Like if for some reason you pick 3 and 6 to go here.
Instead of it being +18, it was -18. That's what I'm saying. Like,
But I have nothing that would combine that way. Three terms, no GCF. This is in the form ax squared plus bx plus c. Which means I can do the A times C method. 1 times 15 is 15. List the factors of 15.
Bro, just messed up.
Now, because the C term is positive, that means that my factors have to have the same sign. And that sign they're going to have is negative. They are both going to be negative.
The thing where I screw up is carrying.
So I'm going to rewrite the B term as negative 3x minus 5x.
Why did you do negative?
Because if they're not, then you have different signs later on.
They have to both be negative because they have to combine to be negative 8. Negative 3 minus 5 combines to be negative 8. What did you want them to be? Both positive?
Yeah.
Remember, if my C term is positive, then my 2 factors are going to have the same sign as the B term.
Okay. Bro, I thought I was doing something.
Okay, that's what we're practicing. Now, factor by grouping. When I group the first two terms together, they have a GCF of x. That's going to leave me with x minus 3. The GCF of the last two terms is negative 5.
Minus 3, because you divide that.
That's correct.
I got stuck on that. Oh.
Divided by the negative. Now, the parentheses match. If the parentheses don't match, that's your sign. You messed up somewhere. Right? Ask for help. That means grouping worked. I can group what's in front of the parentheses times the matching parentheses. Okay, we're going to factor. Is there a GCF? No. Is this a trinomial in the form ax squared plus bx plus c? Yes. That means I can do a times c, which is 6. What multiplies to be 6? 1 times 6, 2 times 3. Now my last term is negative, which means my two factors have to have different signs. One positive, one negative. So I need these to combine to be positive 5, where one is positive, one is negative. So 2 plus 3 is 5, but they're both positive.
So you'd have to go one higher.
So I need to try this one. How can I make these become 5? Subtract 6 minus 1. Is that 5? And they're different signs. So I'm going to rewrite 5x as 6x minus 1x. How did I know which one was positive and which one was negative? Well, because 6 minus 1 is 5. 1 minus 6 is negative 5. That's how you can know. And then bring down the minus 6. Everything else is the same. Right? Nothing else changes from this point on. Group. What's the GCF of the first two? X. That leaves me with x plus 6. What's the GCF of the second two?
Negative x.
They don't both have an x.
Negative 1.
Negative 1 is the GCF. So I need to factor out a negative 1. That's going to leave me with x plus 6. Just walk out when you want to, I guess. Now, this is going to factor to be what's in front of the parentheses, x minus 1, times the matching parentheses, which is x plus 6.
I know that, but like after that, they're both negative now.
Okay, so a times c is,
Negative 14.
we're just going to use 14. It is negative 14.
1 times 14, 2 times 7.
So I need which of these will combine to be negative 5.
Positive 2x minus 7.
2x and a negative 7x. So this is x squared plus 2x minus 7x minus 14. I'm going to group. I get a GCF of x, that's x plus 2. I get a GCF of negative 7, that's x plus 2.
And then it's going to be x minus 7 times x plus 2.
I didn't even know what
No GCF.
Whoa.
Wait, I thought we were
was
doing
thinking
it ourselves. Like,
I really want to get this.
Oh, So if I do a times c, it's 32. What multiplies to be 32? 1 times 32, 2 times 16. The good thing is there's not many things that multiply to be 32. 3 doesn't work. 4 times 8. 5 doesn't work. 6 doesn't work. 7 doesn't work. I've got 8. I'm good to go. I need, which ones of these will combine to give me 12? 4 plus 8, and that's the only one. So we're going to rewrite this as 4xy plus 8xy. And you see how learning this A times C method, even in the easy one, still is going to pay off because it's going to make it a little easier. Here, just trust me, just trust me. Okay. So now I have 4 terms. I like to factor by grouping when I have 4 terms. If I group the first 2 together, what is the GCF? X. They both have an X. So I could factor an X out. That's going to leave me with X plus 4y. Yeah. And then for the last 2 terms, what's their GCF? 8y. They both have a y, and 8 is the GCF for the coefficients. That leaves me with x plus 4y. Do the parentheses match?
Wait. Yeah.
So grouping works. Anytime the parentheses match, grouping's good to go, which means this factors to be what's in front of the parentheses, x plus 8y, times the matching parentheses, x plus 4y.